The next part of derivatives that we'll be looking at is points of inflection and concavity. So a point of inflection, which is sometimes taught with an x or sometimes taught with a ct, responds to a change in concavity of a graph. So we've looked at stationary inflection points before, but they don't always have to be stationary. So a function is concave down in an interval if the double derivative is less than 0, and f is concave up in an interval if the second derivative is greater than 0. So this example, we're going to find the interval where this curve is concave up or down. So when we're looking at concavity, we always find the second derivative. So that's what we're going to do first. So we have our function y equals 2x cubed minus 3x squared plus 4x minus 6. Now we need to find the first derivative of this. So we're going to find dy dx, which will give us 6x squared minus 6x plus 4. And then we need to find the second derivative. Which will be 12x minus 6. Now, from here, we're going to make that equal to 0. And this will tell us where our inflection point is. So if we rearrange this, we will find out that our inflection point is when x equals a half. So finding where the second derivative is equal to 0, that will tell us our inflection point. Now, very similar to where functions are increasing and decreasing, we need to draw a nice number line for this. And we put in our inflection point, which is a half. And now, just the same as we have done previously, we pick a value greater than a half and less than a half, put it into the second derivative to work out what's positive and negative. So I will put in the second derivative at 0, which will give us negative 6. And let's pick a double derivative greater than a half, which is going to be, let's go with 1. And that will give us positive 6. So on our number line here, this is negative and this is positive. It is concave up where it is positive. So that is when x is greater than or equal to a half, and it's concave down where it's negative, which is for x is less than or equal to a half. Now next example, we've got this function 2x to the power of 4 minus 4x squared plus 1. We're going to find and classify all the turning points, find where the function is increasing or decreasing, find where it's concave up or down, and then we're going to have a go at sketching the graph. So the first 3 parts of this, we know how to do this, we've done it before. So we're going to smash through these parts. So I want to find and classify all the turning points. So we're going to find the first derivative, which will be 8x cubed minus 8x. And then to find out where the turning points are, we need to make that equal to 0. And then we need to solve that. So I'm going to factor out 8x, which means from here that 8x equals 0 or x squared minus 1 equals 0. So x equals 0 or x squared equals 1, which means x equal the plus or minus of 1. So we have 3 possible turning points here. Now I'm going to do the second derivative test to work out if they are maximum or minimums. So next step, find the second derivative, which would be 24x squared minus 8. Then put those 3 points, 0, positive 1 and negative 1, into the second derivative to work out if they're maximum or minimum. So if we put a 0 in here, we're going to get negative 8, which means it's a maximum. I'm going to do the double derivative at 1, which will equal 16. So it is a minimum. and then we'll do the second derivative at -1, and we'll find that that is also 16, so it's also a minimum. And then we just need to put those values back into our original equation to find the coordinates. So at the original equation of this one at 0 will give us 1. So we've got the maximum at 0, 1. We put it in at +1 and we get the -1 as the answer. So next turning point is at 1, -1, and then we put -1 in the original function. That also equals -1. So -1 and -1 is a minimum. Now part B, find where the function is increasing or decreasing. So because we did the second derivative test, we need to go back to how we would normally do the first one and draw a sine diagram with these turning points. And we're going to have -1, 0 and 1. So we want to look at a point in between each of these intervals and work out if it's positive or negative. So if you did that, you would find it would be negative here, positive, negative, positive. So remember, that's just picking a value between those intervals, putting it into the first derivative and finding out if it's increasing or decreasing. So this tells us that it is increasing between -1 and 0 and 1 to infinity, and it is decreasing where the gradient is negative. So that is from -infinity to -1 and from 0 to 1. Now part C, we are finding where it is concave up or down. For this we need our second derivative, which is 24x² minus 8, and now to find where it's concave up and concave down, we need to make this equal 0 to find the inflection points. 8 equals 24x², a third equals x², so x will equal plus or minus 1 on root 3. So now to work out if it's concave up or down, we do one of our lovely sine diagrams again, and we're going to have negative 1 on root 3 and a positive 1 on root 3. Pick a value in all the intervals once again to find out if it's positive or negative. You'll find it's positive, negative, and then positive. And the values that we pick in the intervals there, we put into the second derivative formula. And that then tells us it is concave up where it's positive, which is from -infinity to -1 on root 3, and from 1 on root 3 to infinity, and it is concave down where it's negative, which is between -1 on root 3 and 1 on root 3. Now part D is wanting us to sketch this graph. Now when we're sketching this graph, what you need to label on there, you need to label your maximum and minimum points, and we will also mark the inflection points, and that's, remember, where the concavity changes. Now I'm just going to insert a picture of the graph because it's not going to be great me trying to draw it. Alright, there we go. Here's a lovely picture that's already been drawn. So you see here we have the 3 maximum and minimum points. So we have the -1, -1, 1, -1 and 0, 1. Plot them first. And once we've drawn those maximum and minimum points, we also know where things are concave up and down. So with that, it will then help us create this drawing. So the graph here has the intercepts marked on. We weren't asked to do that in the question. It's just always a nice thing to put your intercepts. The 2 dots below the intercepts, these 2 dots here are actually our inflection points. So that -1√3 and 1√3. So that's when the concavity is changing from being concave up to concave down. And in booklet 4, you can now complete the booklet with questions on this topic on pages 9 and 10.